Let's zoom in a little bit here. Let's figure out my position model. I think we did this yesterday, but in case I've lost it, I'm sure. There it's back. It hasn't disappeared again. So remember, it's all the same as linear modeling, except you go to, instead of linreg, quadratic. It's the only difference is quadratic versus linreg. So I'm going to go ahead and store, I'm going to look at the scatter plot first, because I know I turned that off in 243 yesterday. Nothing y equals. There I am. I think we messed with it too, didn't we? We finagled the graph a little bit in class, I think, yesterday. Do we go 0 to 11, I think? By ones. Correct me if I'm wrong on this, friends. 225 by 25s? I think. That looks-ish what we did. Good. And I mean, it's not perfect. This guy's a smidge too high. This guy's probably a smidge too low. But you know what? I mean, it's damn good. It's damn good. And there's my 0, 0. You can't really see him anymore, but he's down here. So you can almost visualize that curve going through it. But I don't want to visualize it. Put it in there. There's where the quad reg comes in. All right, so calc, quad reg. I'm going to stick it in Y1. We can actually play with it a little bit. Done. Whoop. And we have our model. Yes. I'm going to write this down so we have it to talk about on the board. So my model for my distance covered. Ask me those questions if you want to. It's y equals 1.68 x squared plus 2.18x minus 0.37. At least you come on the 0.37 yesterday. Thank you, sister. Now you know what y is? Y is my...
Speed.
Careful, not yet. Speed, we have to do something else with it. What is y? Distance in feet. Yes, ma'am? And what is x? Time in seconds. Very nice. In order to do speed, what do we have to do? What is speed? Ah, that's acceleration. You're one step ahead of me. You're changing my speed. Thank you, Aaron. What is speed itself? What unit do you guys usually talk about in your cars with speed? Miles per... There we go. It's distance over time, Carrie. Thank you. You have to put two of these together to get speed. This is just distance, and this is just the time it took me to do that distance. Speed is going to be the ratio of two of those things. And this is, again, where your project next week is going to drive this point home. It's a compound unit. Feet per second. Feet is just how you measure distance, or one way to measure distance. Seconds is a way to measure time. But feet per time, or feet per second, is a way to measure speed. That's what today is all about, is figuring out what my speed is at varying points along my trip. It obviously was changing. I want to see if I can kind of get the predictability of it under control. Fair enough? So y is distance, x is time. I apologize for this vertical tag on it here. Fair enough so far? Ish. Getting there. Getting there. Okay. So turn this off, because we don't need it right now. I want to revisit an old friend. One of the things I like about Math 105 is the ability to keep bringing old ideas back to revisit. And there's an old idea, and I say old, it's a week old,